1.3, properties of Mips instructions. In this part, actually it's like a summary because most of the properties we have learned in the previous few videos. Yeah. So here, basically we go through those properties and we may add something new. Yeah. All right, so let's look at the properties of Mips registers. Basic properties. First, any of the general purpose or floating point registers, GPRs, FPRs, two types, 32 plus 32, may be loaded or stored except that loading R0 has no effect. Okay, so the first one tells us R0 is very special. It can only contain constant 0. You cannot change its value to a different one. If you load something into it, nothing happens. Okay, but only for this one. Okay, only for R0. For F0, no such property. F0. Okay, floating point. F0. So you cannot use analogy to assume F0 has a similar property. That's not correct. So based on this property, you can easily see that F0. F0 is a regular one. Floating point, regular one. All right, that's this one. Next one, single precision floating point numbers occupy half a floating point register. One full floating point register, 8 bytes, right? Single processing, 4 bytes. So occupy half of it. Conversions between single and a double precision must be done explicitly. Explicitly before you do the operation. Right, half. So here, occupy half of the floating point register. So there is a question. The whole floating point register, can you put 2 different single precision numbers? So based on this one, you can see actually it is. So you can put 2 different single precision numbers there. But how to handle the, complexity, that kind of detail, here for this class, we do not cover that. So we will not go that far. Here we just know a little bit. We just stop at this property, this level. Next one, immediate forms of these instructions. Immediate field, immediate form, are provided using a 16-bit sign extended immediate. Sign extended. I explained this concept before. Remember, when I talk about store integer, byte integer, half word, right? Half word integer, integer, long integer, right? The first 3 type, we can do the sign extended. Here we use the same way. But don't worry. So later in our part E, when we talk about pipelining, so we will do the sign extended verb conversion another time. All right. Next. So these are the typical examples for the immediate forms, these 3 different types. So we saw it in the previous video. So here I do not need to, explain the meaning of these 3 instructions another time. We know all the details. The next topic, using R0. R0, very simple, constant zero, but there are some, special usage for this R0 register. Synthesize popular operations. Here, just give you two examples. The first one, loading constant. Loading constant. So what do you mean loading constant? Loading constant to a register. This kind of special operation, we can use R0 to do it. Loading constant is simply an add immediate field value where the source operand is R0. So we can use this R0 source operand to copy a constant value into a register. So that's what we want to do. The example is like this. You do addition. You do addition. I type ARU addition, but your RT, RS, because this is immediate. This is immediate. Okay, immediate field. So this is RS. This is RT. Okay, So when you do this, you copy constant to a regular register. That's simple. But this R0, because zero value, so you do not change the value of this constant. The second special case, so we call this a register move. This operation is simply an add where one of the source is R0. Another simple example, move operation. Okay? So we just want to move value from R1 into R2. Okay, sometimes we need it, right? Move some value, sometimes we need it. But if you need it, we do not need to define a special operation. We just use existing operation, so this one, but one of the source operand, we use R0. So you can see, you can get what you need in this way. Here, just two simple examples. So you can see R0 has some special usages here. All right, so next, properties of Mips branch instructions. Summary for this part, basic properties. All branches are conditional. So we need to compare. We need to do comparisons, not unconditional. Branch is conditional. All right. So the branch condition is specified by the instruction. Here, the cases, instruction, in which way, the cases here, which may test the register source for 0. So one possibility, so the value stored in a register source location, you want to test, compare it with 0, equal or not equal. That's one case. Another case, the register may contain a data value or the result of a compare. So what's the result of a compare? True or false, right? Sometimes you can do this way. When you compare, two values, compare two values in some way, equal, not equal, greater than, less than, some logic, some, comparison operator. So the result is true or false. Then you can store that true or false as a data value in the register. Yeah. Then another possibility, just compare that value with another register value. Yeah. Yeah. Anyway, just some special type comparisons you can use. Yeah. Here, this example, we saw it several times. Yeah. All right. So another one, there are also conditional branch instructions to test for whether a register is negative and for equality between two registers. Yeah. So this is another version. Yeah. NE. So here, in this example, not equal. Not equal. Yeah. R1, R2, if their values are not equal, then we jump to location specified by this loop. Yeah. Loop, yeah, we could treat it as a label point to another place, but actually internally we know that's the offset, right? Yeah, based on the term we used last video, offset with respect to PC value, right? Program counter PC value. So we jump, yeah. The instruction in the sequence, yeah. So remember, there is an instruction sequence. Yeah. In the normal situation, we follow the sequence natural order, right? Yeah. Okay. Yeah. So this location, natural order, we need to, load this instruction. So this address is stored in PC. All right. But because we have a branch instruction, all right. So if the condition is true, so not equal, correct, right? Yeah, condition true, then you jump. So that's the offset, okay? Yeah, offset, loop, yeah, offset, yeah, jump to somewhere, okay? Whatever, somewhere in the sequence. Yeah. So that's the typical meaning here, yeah. All right, so the next one, there is also a branch to test the floating point status register for floating point conditional branches. Yeah. For floating point, yeah, so there are some, but here we do not go to that kind of details. Yeah. Yeah. So we know, so there is, some special things we need to do for floating point. Yeah, but, we do not learn the details, related to floating point branch instructions. Yeah. So when we use examples, we only consider the integer value branch instructions. Yeah. For simplicity. Okay. Yeah. All right. So that's the